Okay, here we go. I want you to turn to page 663. We are doing lesson 11.7. We are doing problem solving areas of rectangles. Now you're just taking what you know about area and we're just going to solve problems. Essential question: how can you use the strategy find a pattern to solve area problems? Well, that's what we're going to do. We're going to solve area problems. Our learning objective: you will use the strategy find a pattern to solve area problems by recording measurement data in a table and looking for a pattern of change in the relationships. Okay. You will understand that in just a minute. We are just going to solve problems using area and putting it in a chart. Okay? All right, let's start. Unlock the problem. Mr. Coy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the areas of the buildings are related. How does the area change from the area of building A to the area of building B? How does the area change from the area of building C to the area of building D? Use the graphic organizer to help you solve the problem. Down here is our graphic organizer, our chart. Okay, now these are the buildings: building A and building B, building C and building D. What we're going to do first is we are going to find the area of each of the buildings. So let's look here. I will complete the table to find the patterns to solve the problem. Well, look at area A. We have the length is 3 feet right here. What is the width? 4 feet. So the area of that building, we know area, multiply. We're going to multiply. Don't forget that when I say area, I want you to think of a big X right in the middle of it. I want you to multiply, okay? So 3 times 4 equals 12 square feet, okay? Now, that was for building A. Let's look at building B right here. It says the length is 3 feet. So what is the other side? The other side is 8 feet. Okay? So if we multiply, if we know that that's 3 groups of 8, 8 plus 8 plus 8, or 3 times 8, which is 24 square feet. I just abbreviate it and just put S period Q F period. Okay? Now, for building C, same here. We have, it gives you the width. It gives you 4, but it doesn't give you the length, which is 6 feet. It's just the other side of the rectangle. Okay? Well, 6 times 4, my favorite product in the world, 24 square feet. The next one, building D. We have 8 feet. So what is the length? It is 6 feet. Okay, 6 times 8. Well, wait a minute. I know 8 times 5 is 40. If I add another 8, that would be 48. You're exactly right. 48 square feet. Don't forget your strategies for multiplication. I can see that the lengths will be the same and the widths will be double. So right here, the lengths are the same and the widths are double, 4 and 8. So the area will change from 12 feet to 24 feet to 24 square feet. And from 24 square feet to 48 square feet. So when the lengths are the same, do you see that? It's the same length, but the width was doubled. It went from 4 to 8. Here, the lengths are 6, but the widths are doubled. It went from 4 to 8. When you do that, then your area is going to be double. It's going to be doubled also, okay? All right, let's move on because we need some extra work on this. Okay, we're going to try another problem. Mr. Coy is building more storage units. Well, good for him. He wants to know how the areas of the buildings are related. How does the area change from the area building E to the area building F? How does the area change from the area building G to the area of building H? Okay, we're going to use our graphic organizer. We are going to find our area of each building first. Okay, so let's look at that. E, what is our length? 8 feet. Oh, wait a minute, I'm sorry. Let's do 5 feet. Okay, and then our width is 8 feet. Either way works. 8 times 5 is 40. 40 square feet. Okay, building F. We have one that's 5 feet. The length is 5 feet. And the width is 4 feet. Uh-oh. So what do you think is going to happen? It went half. The width was cut in half. So what do you think the product, the area is going to be? You guessed it. It's going to be cut in half too. So let's look at G. Okay, both of them have 10 feet. So let's do the length is 10 feet. Okay, what's the width? On G, it's 8 feet. On H, it's 4 feet. Huh. The length is the same, but the width is half. So what do you think is going to happen to the area? Let's look at that. 10 times 8 is 80 square feet. So what do you think 10 times 4? 40. The area becomes half. Okay? All right, let's move on. We're going to do this. Okay. Many pools come in rectangular shapes. How do the areas of the swimming pools change when the widths change? Complete the table by finding the area of each pool. Okay? We are going to find the area, so we need to multiply length times width. So let's look at this. 8 times 20. We'll just take the 0 off of 8 times 20. Just take that 0 off. What's 8 times 2? It's 16. And then slap that 0 on it. So it's 160 square feet. Same thing. 8 times 30. Uh-oh, we're going up 10 feet for the width. Well, what's 8 times 3? It's 24. And then we slap a 0 on it. 8 times 40. Well, that's the same as 8 times 4 and then slapping a 0 on it. 8 times 4 is 32 and then slap a 0 on it. 8 times 50. 8 times 5 is 40 and then slap a 0 on it. Don't forget to do that. Okay? All right, ladies and gentlemen. The length stays the same, right? We're looking for patterns now. The length stayed the same. The widths, what is going on with the widths? Well, they increase by 10, don't they? They go up by 10. Okay? So we're going to describe the pattern of how the area changes. The areas, what do? Do they increase? Yep, they're going up, aren't they? They increase by how much? Well, 160, 240, 320, 400. Let's see here. 240 minus 160, bigger bottom borrow. Oh, it's 80. Well, if I do 320 minus 200, it's going up. Each one of these are going up by 80. Okay? All right. Let's see what we got here. All right, ladies and gentlemen, what I want you to do, I want you to do your homework now. If you are still unsure what is going on, I want you to do the rabbit video. Okay? Thank you.